Hello, this is Ted Moreno, the Director of Solutions Marketing for Lattice Semiconductor, and I'm going to walk through for you the DSI demo, the DSI receive and transmit demo that Lattice has put together. I think, as you know, the DSI interface is based on the MIPI D-PHY, which is a bus that supports both CSI2 and DSI. So because of that, what I actually want to do is give just a quick overview of where these interfaces come from and some of the challenges that the broader market will have in utilizing these interfaces. So if you actually look at the camera architecture, or excuse me, the smartphone architecture, you'll see that the D-PHY buses are for both CSI2 as well as DSI. So the interface to the apps processor to the display, and also from the apps processor to the camera, has that DSI and CSI2 bus, which is based on the D-PHY. Now, in the embedded market, a lot of times someone will have a image sensor or a screen that doesn't have CSI2 or DSI. And if they want to use an apps processor, we can help bridge it. So, for example, they might have a screen that has LVDS interface and an image sensor that has just a parallel bus. The other potential is that someone wants to use an embedded processor and they want to drive a display. Well, that may only have LVDS or an RGB bus. And likely an application processor, if you wanted to interface that to a screen or an image sensor that was targeted for surveillance or other market, the application processor usually only has CSI2 and DSI for interfaces. And so, this becomes a challenge, right? You have a processor, a microcontroller, a microprocessor that has an RGB type interface or LVDS, and you want to drive a DSI screen. You just cannot connect those together. Same problem if you have an image sensor that is targeted for DSLR or another market. It is not going to connect because it's sub LVDS, and it won't connect to an apps processor that has CSI2. So this is really the value of what Lattice is bringing, is the ability to bridge these. And we're making this very straightforward for users. We have 4 web pages for the CSI2 receive, CSI2 transmit, DSI receive, DSI transmit. And each web page will have a button, a Start Here button, that allows the user to request exactly the specification that they want. So you will be able to go to a web page, and on each web page it'll have a block diagram, a typical block diagram. In this case, we're just showing you a DSI receive, where we're interfaced to an apps processor and then driving an embedded screen. But the point is that you can see the Start Here button. The user would click that, and then there would be a form they fill out, and we provide them a custom configuration. Okay, so what I want to show you at this point is the DSI actual demo. What I have in front of me, that my hands are on, is a Pelican case, and this is very similar to what we'll be shipping to the field. This is the DSI demo kit. So let me just show you the kit itself. Has a board here with a display and a power supply right here. I'm going to remove some of the foam and just take out the power supply. Then the other thing you'll notice is the board and the display are mounted on this plastic backing. So that's really important. These connectors that you see, where we have made some connections in between the boards, are actually fairly fragile, and we wanted to make the mounting here so this would be much more solid. So I want to take that out, and we'll just move the Pelican case out of the way. Okay, so we'll put the board and the screen down right there. So this demo is very straightforward. What we're actually doing is we're interfacing from a Snapdragon processor, an application processor, which is right here, through an X02 and then to a screen. Before I do that, obviously I'll need to plug it in. So it's very simple. You just take the power, and then there's a connector right here. Just plug it in, and then the demo will boot and do everything else that you need. Now, what we're actually doing here, this development kit is a Qualcomm Snapdragon 8060A, and normally this is connected directly to the screen. But what we've done is we've made this interposer board that has an X02 on it. So the Snapdragon drives the X02, and that's the DSI receive function. The X02 actually converts the DSI to bytes, and that's a serial to parallel function. And then we take those bytes and convert it to pixels, and then what we do is we actually have a Lattice logo overlaid on the screen, and you can actually see it as the screen is popped up here. So we are able to show that after we convert the pixels and we do the overlay, then we convert it back to bytes and serialize and drive the screen. So what you'll notice here in this demo is the Lattice logo appears in the left corner, upper right corner, lower right corner, lower left corner, and then in the middle. And then it will scroll across the screen on the top, and then it scrolls on the bottom. Then it will just repeat its own function. So let me just give you a little bit more of a close-up just in case you cannot see. Might have a little bit of a reflection here. I'm trying to give you a good idea of what the screen is actually doing. So hopefully you can see that. The logo is moving from different places, and it's just overlaying on the screen itself. So independent of what I touch or how the screen moves, that logo just goes and repeats the function. So this shows clearly that we're able to receive DSI, convert it from bytes to pixels, and also go from pixels to bytes and drive out DSI to this display. Okay, I just thought it would help if I showed you an alternate shot, because I don't believe the screen was really visible in the other shot. This is an image of the screen, and you can just see the Lattice logo moving around. So I'm just touching the screen every once in a while just to make sure it doesn't power off. If it does, there's actually a push button next to this red light over here by the Qualcomm Snapdragon, and if you push that, it will repower the device if the screen does shut off. But you can see very clearly that the Lattice logo is jumping from the upper left to the upper right, and then the lower left, lower right, and then in the middle. Then it goes up to the top and scrolls across as it's doing right now, and then shortly you'll see it in the middle of the screen scrolling down. Then it just repeats what we talked about. So this is very compelling to show customers that we're able to receive DSI, manipulate an image, and then actually output DSI as well.